deletion from the AVL tree. Okay. So as we said, AVL tree is a balanced, close to balanced binary search tree. Okay. And whenever we do a operation, like insertion or deletion, both operation can actually ruin the balanced condition of the AVL tree. Now, if the binary search tree gets unbalanced, the properties of AVL tree is that the AVL tree is a self-balancing binary search tree. Means for every operation, for each operation, if the AVL tree gets unbalanced, it will by itself, it is going to balance itself. Means it is going to rebalance the tree. Now, these two are the operation like insertion and deletion that can ruin the balanced condition of an binary search tree, means AVL binary search tree. So last class we saw that after insertion, how we can do the rebalancing. So there are four rotational algorithm. All right, based on the condition, we are going to implement the rotational algorithm and we can rebalance the tree. And now there are another operation is deletion. Okay. So we have a AVL tree. AVL tree means this tree is balanced. Now we are deleting a node. So after we delete a node, that could also ruin the balance condition of the AVL tree. And today we are going to see that how after deletion, how we are going to rebalance the tree. Okay. Now here also we are going to need the rotation, the same rotation algorithm, the same 4 rotation algorithm we are going to implement. But for deletion, we have to consider couple of cases. Okay. All right. So before that, we are going to know the factor. We are going to know the term known as balance factor. Okay. So the balance factor, or in short, we can write also BF. It's actually for every node, there is a balance factor. Okay. So for each node, there is a balance factor, and we're going to calculate the balance factor like as a height of left subtree minus height of right subtree. Okay. Now, if a tree is a AVL tree, in that case, for each node, the balance factor would be either -1 or 1, either -1, 0, or 1. Okay. So if the tree is a AVL tree, in the AVL tree, for each node, the balance factor will be either -1, 0, or +1. Okay. So whenever a node gets actually a balance factor, which is like -2 or +2, okay, it doesn't have to be +3 or -3, because whenever a node gets the value -2 or +2, that means this tree needs a rebalancing. Okay. All right. So here it means that if the balance factor is like -2, that means actually the that means actually the right, sorry. Yeah. So if the balance factor is -2, that means actually the right side is heavy. Okay. The left side is lighter and the right side is heavy. And if the balance factor is +2, means actually for a tree, the left side is heavy, for the right side is actually lighter. Okay, that's it. So this is the term balance factor, and for deletion we have to actually consider the balance factor for each node. Okay. All right, so let's see couple of condition, let's see couple of case that can happen in AVL tree with deletion. Okay. Now let's see the first case, that means if we are going to delete from the right subtree. Okay. So we have a tree, looks like that. Let's see, that's almost balanced. I'm saying almost balanced. Maybe the difference could be actually like +1 or -1, right? The difference could be, absolute difference could be 1. So if I delete something from the right subtree, means which side is going to get heavier? The left side, right? So I am deleting something from here. I'm deleting something from here. Let's see, from the bottom level, and it could be also the upper level than the bottom level. But if I delete something from, but the tree is balanced, but I'm deleting something from the left subtree, and because of that, the tree get unbalanced. Okay, some of the node gets unbalanced. That means actually, the left subtree will get heavier, okay, than the right subtree. All right, so these are some intuition we are going to actually follow, and there are actually a couple of like specific case we are going to see. All right, after we delete from the right subtree, we are going to actually, starting from the node that we are deleting, starting from that node, we are going to again calculate that whether this tree gets unbalanced. Means for each node we are going to calculate the balance factor, and we are going to find out the node that gets unbalanced first. Okay, so let's see one example for this case 1. In this case, we are going to, for case 1, we are going to delete from the right subtree. Okay. All right. So let's see, we have, uh, we're going to find something like that. Let's say we have a tree, something like that. Okay, so this tree is balanced. So this tree is balanced because for every node the balance factor is actually the difference is 1. Okay, now let's see, we're going to delete 5. All right, now we're going to delete 5, and what happens? So now the deletion operation is exactly like binary search tree. Okay, so we are going to delete exact using the exact algorithm that we do using in the binary search tree. So 5 is a leaf node, so that is going to be simple. So we are going to, it is going to be just like that. Okay, all right, so here we are deleting from the right subtree, and what happens after we delete from the right subtree? So after we delete a node, starting from that node, actually we are going to go at the upper level, and we are going to calculate the balance factor for each node. So when we delete the node 5, starting from this level, we are going to calculate the balance factor for each node. Okay, now there is no changes in the left subtree, so that means in the same level, the left subtree, everything will stay same. Okay, so we are going to calculate the balance factor for only node 4. In its upper level, we have the root node. So starting from this level, we are going to calculate the balance factor for every node. So for node 4, the balance factor here is okay, so the balance factor here is +2. Okay, so the left subtree is heavier, the right subtree we don't have any node. And for the balance factor of the left children of the node that is unbalanced, here we have +1. So in this case, when we delete a node from the right subtree, if the case is that the balance factor of the node that gets unbalanced first, for that node, if the balance factor is +2, and for the left children, if the balance factor is +1, okay, we're going to do LL rotation. All right. So from the picture, actually, you can see that we're going to need a LL rotation. So here, I mean, intuitively, you can think that we deleted from the right subtree, but we are doing the rotation from the left side because actually the left side gets the heavier. So we have to do something including the left subtree. Okay. So if the condition is that this node, unbalanced node has plus t plus 2 and the left child has plus 1, we are going to do LL rotation. And after we do the LL rotation, what happens? 2 will become parent, 4 will become the right child, and 1 stays same. Any question? All right. So let's see another example. Let's see, we have a tree. Still, we are considering deletion from right subtree. Okay, so let's see, we have a tree like that. Okay. So this tree is balanced for every node. The difference is actually 1 or 0. Okay. Difference between left subtree and right subtree is either 1 or 0. Now let's delete 40. Okay. So what happens? 40 is a child, 40 is a leaf node. So that will be simple. Okay. So now the tree becomes this, like this. So here also you can see that my left side is getting heavier. Okay. And what is the condition here we are getting? So starting from the 40, we are going to, I mean, nothing will change in the left side. Only thing is going to change in the right side and upper level of the, from that node. Okay. Upper level of the node that we are deleting and only in the right side. So starting from the node 40, after we delete 40, starting from the node 40, we're going to check every node on the right side and we're going to go only at the upper level. So in the upper level, we'll find that for node 30, 30 has actually the balance factor will change now other than before deletion. So now here balance factor here is 2. And what is the balance factor for 10? -1. Okay. So we are deleting from the right subtree. So left side will get heavier. So we are checking the condition is that for the node that gets unbalanced, his balance factor will be, obviously it will be +2 or -2. Okay. If this get unbalanced, that means it is going to be either +2 or -2. Okay. So we are deleting from right subtree and left subtree gets heavier. So it will be +2. And for the left children, it is -1. -1 means actually for these children, it doesn't have any children. I mean, it for this node, okay, for this node, its right subtree is heavier. Okay, minus means its right subtree is heavier and left subtree is lighter. So -1. So that means we're going to need a LR rotation. All right. We're going to need a LR rotation. So LR rotation means first we're going to rotate in the left, then we're going to rotate in the right. So it will look like that. First do the rotation in left, it will be 30. We rotate in the left, so 20 will become parent, 10 will become child. Okay. Now rotate in right. LR rotation, first we're going to rotate in left, then we're going to rotate in right. So it will become 20, 10, 30. All right. Let me know if you have any question, because when I'm teaching, I am not going to check actually the chat box. Okay. All right. Now I'm deleting from the right subtree. So the node balance factor, the node gets unbalanced. It will be +2. Now what about the balance factor of the left child of that node? Now it is 0. So this case can happen. It may look like that. Say we have 13. Okay. So the tree looks like that, and this is a balanced tree. We can see that. Okay. Now let's delete 40. Okay. So after we delete 40, the tree will look like 30, 20. All right. So in this case, what happens? From 40, we are going to check every other node from the upper level. And in the right side, we're going to start from the right side, and we're going to check every node from the upper level of 40. So we'll first find the 30, node 30. It is the balance factor is +2. And for the left children, left side gets heavier. So for the left children, we check that the balance factor is 0. Okay, so this node is completely balanced, but for the node 30, the balance factor is +2. Okay. All right. So in this case also, we're going to do LL rotation. And LL rotation means actually we're going to consider this 3 node only, and that will become like 10. 10 has the left children 5, and 30 will become the children of 10. Okay. Now right child of 10. So the 10 has already a right child. So 20 will become the left child of 30. Okay.
I had a quick question,
Yes.
Professor. So during if you can go back a slide. So like during this right here, right here. So like, will a question like this always kind of like tell us to do an LL rotation, or like,
no.
will it be like, hey, we could do a left right here?
You are going to decide which notation you are going to need.
Okay.
These are the case. Okay. So you are deleting from where, and based on that, you are going to find out that which node gets unbalanced. So you are going to calculate the balance factor for that node that gets unbalanced, and you are going to calculate the balance factor for left children if you are deleting from the right subtree. Okay.
Yep.
All right. So based on the condition, you are going to decide which rotation you are going to do. All right. Any more question? All right. So now case 2 includes when we delete from the left subtree. So what happens if we delete from the left subtree means we are deleting from something in the left subtree from a balanced tree. Okay. We're deleting from something from here, and the node gets unbalanced. That means our right subtree is getting heavier. And what will happen to the balance factor of the node that gets unbalanced? It will be like -2. Okay. It doesn't have to be -3, -4, because whenever it will get to -2 or +2, that means actually the tree needs a rebalancing. Okay. So that's why only we are checking this condition that the balance factor is -2 or +2. All right. So we are deleting from the left subtree and we are checking the condition. The first condition could be the node that gets unbalanced is balance factor is -2. And now we are going to check what is the balance factor of the right child of this node. So let's see one example. Let's see, we have a tree like that. 30 and 40. Okay, and we are going to delete 10. All right, so the tree will become 20, 30, 40. All right, so the node will gets getting unbalanced first is the node 20. So its balance factor here, you can see that it's -2, here is -1. So the balance factor of right child of this node is -1. So that means we are going to need a RR rotation. So we are going to need a RR rotation like that. So RR rotation means actually we are rotating it in left. So we are going to pull 30. So right side everything will be okay, but the parent will be the left child. Okay. The case 2, I mean, we are deleting from left subtree. All right, but the balance factor for the node gets unbalanced will be -2. And let's see the right children of the node is +1. So let's see one example how that can happen. So let's see, we have 20, 10, 30 and 25. Okay, and we are deleting 10. We're deleting from left subtree, so we are deleting 10. So after we delete 10, it will look like 20, 25. So what happens starting from the 10, we're going to check the balance factor for each node. And what happens for this node is its balance factor is -2. Okay, balance factor is -2 now means right side gets heavier, and we're going to check the balance factor for its right child. So for the right child, the balance factor is actually +1. Means for these children, for this node, its left side is heavier, the right side is lighter. Okay, means we are going to need a RL rotation. So in the RL rotation, we are going to first rotate in the right, then we are going to rotate in left. Okay, so first right, then it will become 20, 25, 30. All right, and then it will become, then we are doing the rotate in left. Okay, and it will become 20, 30. All right, all right, so probably this is the last case. Yeah, so we're deleting from the left subtree. Okay, so the balance factor of the node gets unbalanced will be -2. And let's see that for the right child the balance factor is 0. So it is going to look like that. Say 20, we have say 10 here, say we have 30, 25 and 40. Okay, now we are going to delete 10. We're going to delete from left subtree, so we are going to delete 10. So after we delete 10, it will look like, all right, So what happens here? We're going to calculate the balance factor for every node, and we're going to see that for node 20, the balance factor becomes -2. Now we're going to check the balance factor for the right child, and it is 0. Okay. So if the balance factor is 0, means for this node actually both side is in the same height. Both side has the same height. So here also we are going to do the RR rotation. So after we do the RR rotation, so for after we do the RR rotation from starting from this node, actually this node will be now parent, right? So for this node, actually the difference will be, I mean, the absolute difference will be 1. All right. So, but we are going to, that's why we are going to do the RR rotation. So what happens here after we do the RR rotation, it will become 30. So 20 will become the child of 30. Now 20 becomes the right child of 30. Now 30 already has a right child 25. So 25 will become the right child of 20. Okay. Actually, you can, we are going to make it, yeah, 20. So 20 will become the right child of 25. Okay. Like that. So that's how we're going to do the deletion. So what actually I'm going to do, I'm going to actually give you one example. Now let's work with an example. So for all the example we saw actually just a couple of nodes, like 4 to 5 nodes. All right. So it was like kind of easy to visualize what type of rotation we are going to need. Okay. But our tree may look like actually slightly complex than that. But the following the same rules that actually you can apply. So the first, in the algorithm, first you are going to check that we are deleting the node from which subtree, either left or right. So based on that, either left or right, based on that, we are going to calculate the nodes that gets unbalanced first. Okay. The node gets unbalanced first. For that node, we are going to calculate the balance factor, and we are going to calculate the balance factor of the left children if we are deleting from the right subtree, or the balance factor of the right children if we are going to delete from the left subtree. Okay. So no, I'll see the example actually right now. Just a minute. So okay. All right. So here, so I'm going to actually draw a tree, and from that we're going to delete a node, and we're going to find out that what type of rotation we're going to need for the rebalancing. So let's say we have a binary search tree, AVL tree, like that. So 17. Okay, and it has a right child 32. Okay, so first question, is that a AVL tree? This one is actually an AVL tree, actually, like for every node. Yeah. So let's see, we're going to delete 32. Okay. So we're going to delete 32. So 32 is here. Okay, and which subtree I'm deleting? I'm deleting from left subtree. Okay, so first let's delete 32 and then check that whether this node gets unbalanced or not. Then we're going to check that which subtree I'm deleting. I'm deleting from left subtree. Then we are going to check if the node, if the tree gets unbalanced. Okay, then we are going to check further condition. Okay, and we are going to find out which rotation I'm going to implement. So after I delete 32, the tree becomes 42, 17. Okay, all right, I'm deleting from left subtree. So obviously now starting from the node that I deleted 32, I'm going to check the balance factor for every other node in the left subtree, and I'm going to check every other node in the upper level. So I mean in the same level, actually the for the right subtree I don't have to check anything because it is not going to change. Okay, but for 32, after I delete 32, I'm going to check the balance factor for 17. Okay, for 17 the balance factor here is 0. Now I will now check everything in the upper level. So what happens for the node 44? What is the balance factor?
-2.
-2. Okay, I deleted in the left subtree, so the balance factor here gets -2. So it means the node is unbalanced. I don't have to check any more node, okay, in the upper level. And it's already root node, but it may not be the root node. But whenever I will find a node gets unbalanced, I needs the rebalancing. All right. So when this node has -2, which node I'm going to check further for the balance factor?
78.
Sorry. I mean, I deleted from the left subtree, the node gets unbalanced. That means actually, and the balance factor is -2, I can see that. That means which side is heavier?
Right side.
Right side. So this node I'm checking the balance factor, and the further which node I'm going to check the balance factor for its right children, immediate right children. Okay. So I'm going to check for the node 78. I'm going to check immediate right children 78. What is the balance factor for 78? So here the balance factor is here. I have actually 2 here, 1. So the balance factor is +1. It means that for its right children, the left side is heavier, the right side is lighter. Okay. So left side is heavier, the right side is lighter. So in that case, what do you think? I mean, you can just browse all the rules and let me know which rotation I'm going to do now.
I would do a right left, but I don't know if that's correct.
Sorry?
I would do an RL rotation, but I don't know if that's correct.
I mean, you can be sure actually we went over all the case, right? So you are finding a specific case where the balance factor of the node is -2, and for the right children, balance factor is +1. Okay, there is a specific case, and I can see here. Sorry, I deleted from the left. Okay, so I guess this is the case, right? So this is the exact case I'm talking about. I deleted from the left subtree. I deleted 32 from the left subtree. So the right subtree gets heavier, and the balance factor, if the tree gets unbalanced for a node, I will find the balance factor will be -2. Then I will check the balance factor for immediate right child, and it now I'm finding +1. So this is the case. So what I'm going to do, I'm going to do RL rotation. Okay. So I'm going to do RL rotation, right, left. So that means including these 3 nodes, I'm going to do the RL rotation. And how this is going to look like? Do some of you want to do that? Just spend like 5 minutes, okay? Do that, and I will actually show you the solution. Just try it by yourself. I'm going to do the RL rotation, means actually first I'm going to do rotate in left between 50 and 78, okay? Then I'm going to do the rotation between actually for 50 will be the children, so the 50 and 42 44. Okay. All right. So after you do the changes, which one becomes parent? I mean, which one becomes the root?
50.
50, right? So let me show. Okay, let me just do over. We're going to do the RL rotation. So we decided, I mean, based on the case, we find out that we are going to do the RL rotation. Okay. So first rotate in right between 50 and 78. Okay, so after we do the rotate in right between 50 and 78, the tree will look like that. So 44, 50 will become parent, 78 will become children. Okay, now when 78 will become children, 88 it's its own children. Now 50 has a 50 has all 50 78 becomes the right children of 50, so 50 already has a um, right children, so these right children 62 will become the left children of 78. Okay, and 50 has 48 and 44 has 17. Okay, that's actually the first one rotation, first r rotation. I mean, when we did the rotation on r, the whole tree will become like that. Okay, so the after first rotation it becomes like that. Then I'm going to do the rotation between uh, 50 and 44 in the rotation in left. Okay, now do the rotation in left. Now it will become 50 will become parent, 44 will become children. Now 50 had already a left children 48, so 48 will become the right children of 44. Okay, that's the change actually I need, and everything will stay same. 78, 62, 88, and 44 has another children 17. Yeah, so that's the change. I mean, after the rotation the tree will look like this. Okay, any question? Any question? Okay, so now let's work with another exercise. So here actually we are going to see one exception between insertion and deletion. So in insertion and deletion, in both cases actually we are seeing that the algorithm is actually same for the rebalancing, right? Either we are doing LL, RR, RL or LR, all right? But in the insertion, after every insertion, we need only one rebalancing. Okay, means we are inserting a node, the tree, if the tree gets unbalanced, that means actually I have to do just one rebalancing rotation. Okay, either single or double, but one rotation. I mean just one rebalancing. Okay, either double or single, but one rebalancing algorithm I have to apply. That means after I done rebalancing for once, the tree will be balanced. Now for the deletion, actually there is a exceptional case can happen. Means I deleted a node. Okay, one node gets imbalanced. All right, one node gets imbalanced, and I do the rebalancing. So it can happen that after the rebalancing, the node, the following the algorithm, I done the rebalancing, but the whole tree may get stays unbalanced. Okay, so we're going to see an example